Now, as we start Unit 5, I want to just remind that you can always go to Canvas and go to My Lab in Mastering. Click on that. Then click on Open My Lab in Mastering, and then go to Multimedia Library. Go to the module we're dealing with, which is Chapter 5 or Unit 5. Matrices and determinants. Click on that. Go to the section you want to work on. 5.1 is the one we're going to work on. Now I've done the PowerPoint slides, and by clicking here, this is where you would get the PowerPoint slide. But you might click here as well, Section Video Lectures, where I give my shot at it and other instructors would give those. So you click on that, and lo and behold, there is a video now that will take you through the topics done in a similar way to what I have been doing. Just to let you know, that is another option. We can also find the online textbook. There are some chapter test prep videos. These are the PowerPoints that I've used. And let's go back now to our regular lesson. So starting our lesson, matrices and determinants. Matrix solutions to linear systems. Now, throughout these, we will be dealing with major vocabulary and symbolism. We'll be looking at the Gaussian elimination method to solve these systems, and then later looking at the Gauss-Jordan elimination method to solve systems. Now, what is a matrix? Well, matrices are used to display information and to solve systems of linear equations. Singular is matrix, the plural is matrices, and it's done in a rectangular array. The information is arranged in rows and columns and placed in a bracket, big set of brackets. The values inside the brackets are called elements of the matrix. So an example of a matrix is one that we see here. So as we look at this, these are the rows. So this would be like considered row 1, and this is row 2. And then vertically, we have our columns. This is column 1, and this is column 2. Now, we often define a matrix then as a product of how many rows and how many columns we have. So we would describe this one as a 2 by 2 matrix. And the items inside the brackets would be the elements of a matrix. Now, the first step in solving a systems of linear equations is to use matrices, is to write what is called an augmented matrix. That is, you've filled it in from something. It has a vertical bar separating the columns of the matrix into two groups. General form would have a bracket, and then a vertical bar here. On this side would be your variables, and on this side would be the coefficients. If any variable is missing, we would put a 0 in that spot to set it up in the proper form. All right, let's take a look at our next slide. Now, in order to set up a matrix, you must have the equations in standard form. So this would be like ax plus by plus cz equals some constant here. So these are set up properly. This is the system of linear equations. And this one, of course, is in 3 variables. So modifying this to its matrix form, we then take just the coefficients, the 3, the 1, the 2, and the 31, and put them in the matrix form, where this vertical line is equivalent to equal signs here. So line 2, this would be a 1, a 2, a 19. A 1, a 2, a 19. And this one would be a 1, a 3, a 2, 25. 1, 3, 2, 25. Now, one where there are only fewer things, there's no x variable, for instance, you'd put a 0 there. Here you would put 2 zeros to make up for the missing variables. So again, this is a 1, 2, negative 5, 19. 1, 2, negative 5, negative 19. 0, 1, 3, 9. 0, 1, 3, 9. And then here, 0, 0, 1, 4. All right, so this is sort of straightforward, just converting from a linear equation into the augmented matrix. Now, another key vocabulary word is matrix row operation. Now, what we're looking for eventually is to get what is called a main diagonal, which looks like that, where this term is a 1, and then below that 1 is a 0, and then this is a 1, and below that 1 is a 0, so that you have 1 in the first row, a 0, 1 in the second row, a 0, 0, 1 in the third row, and this is now set up in what we call row echelon form. And we saw this actually in the previous slide. So let's go back one. And we see it here. There's a 1, there's a 0, there's a 1, 2 zeros, and a 1. And your main diagonal are 1s. And we see it repeated here. All right, so take some notes. You need to be familiar with what's going on. And we might add at this stage that this is considered row 1. This would be row 2. This would be row 3. Again, getting used to the symbolism of the matrix. Now, another key term, and which allows us to use matrices to solve, is matrix row operations. And again, we'll see all of this developed. So, number 1, 2 rows of a matrix may be interchanged. This is the same as interchanging 2 equations in the linear system. And we indicate this, for instance, row 1 is going to be interchanged with row 2. Item 2, the element in any row may be multiplied by a non-zero number. This is the same as multiplying both sides of an equation by a non-zero number. So if you were going to multiply row 1 by 3, let's say, you would indicate it this way. This is the symbolism for saying you're going to multiply row 1 by 3. Now, item 3. The element in any row may be multiplied by a non-zero number, and then these products may be added to a corresponding element in any other row. So suppose that we wanted to multiply row 1, every term by 3, and then add it to row 2. This would be the symbolism for that. And again, you'll see examples of this as we go on. Now, the two matrices are row equivalent if one can be obtained from the other by a sequence of row operations. So what are our row operations so far? We can change one row with another, and we can multiply one row by a non-zero number and then add it to another row. That would give you an equivalent row as a second row in a sense. All right, we're going to see this in action very shortly. So repetition is great. So for row or item 1, interchange the elements of one row with another row. This is the symbolism for it. Multiply each element in a particular row by some number. So this would be, let's say, row 1, that you're going to multiply everything in row 1, let's say, by a negative 3. And then add that to some other row. So this was row 1 here, multiplying everything by a negative 3 and then adding it to row 2. These are called matrix row operations. Now, if you're taking notes on this, you should be using our example numbers. This is example 1. And here's our given matrix. Now, one of the first things you do is study it a little bit. And you might say, oh, look, row 2 here has a 1 in its first position already. So let's exchange row 1 with row 2. And how would we define that or write it? Well, it's right here. Now, what indicates in this symbolism that you're exchanging rows? Well, this arrow on both sides, in a sense, this symbol. Okay, so let's see that in action here. Now, take a moment. You want to write this down. Now, you're going to use lots of paper for these kinds of examples, and it takes quite a time to do them. And you have to be very careful you're following the protocol. So we've just exchanged row 1 with row 2. Now, as you do these examples, there is no absolute one way to do it. Another way to get row 1, as it originally was, to have a 1 in this first position, is to multiply each term here, as you study it, by 1/4. So how would you indicate that? Well, you're going to go 1/4 of row 1. It's going to give you a new row 1. And let's just do that. So 1/4 of this becomes a 1. 1/4 of this becomes a 3. 1/4 of this becomes a -5. And that, I don't mean to put that comma there. And 1/4 of 8 becomes a 2. So this is another kind of thing you could have done instead of switching rows. But since row 2 is this new one here, I could do that to row 2 as well. All right, a number of things can be. Now, as we continue to illustrate row operations, we did this and we have this. Now, studying this for a moment, suppose we want to get this row to eliminate one of the variables or one of these numbers so that we have a 0 somewhere. What can we do? Well, here we can multiply row 2 by what value so that it becomes a -3. So that when we add it to row 3, this is going to become a 0. Well, if we multiply row 2 by a 3, this is going to become a +3. This becomes a +18. This becomes a -9, and this becomes 21. But now when we add it to this row has a +3 for this first term, -3. This is going to become a 0 here. All right, let's see it in action. So there's our matrix. We're going to do the row operation of multiplying row 2, which is this row, by a 3, the symbolism, and then add it to row 3. And let's see what we get. So there's our row 1, or I should say our 1 in row 2 that we're going to multiply by 3. So 3 times 1 is 1 plus 3. I can write this out for you so you can see it in action. This is going to be a 0. Now this is going to be row 3 here eventually. Now, and again, we're multiplying this row by 3 and then adding it to row 3. So 3 times 6 is 18. Minus 2 gives me a 16 now. 3 times a -3 here, -9. Added to the third row, 1, -8. And then 3 times 7 gives you a 21 minus 9 is 12. So again, following what we're doing slowly and carefully, let's see it here, gives us our new matrix as we see right there. Okay, let's pause. So this example was showing you the kinds of things that can be done when we use row operation. Now notice we don't have a major diagonal that are ones and these are 0, 0, 0. We didn't solve this yet. That's coming up in our next example. Here it's just showing you how in a beginning step we use row operations. Now here they're putting it all on one slide. Eventually what you want to do, and these examples do take time, first set it up as your augmented matrix, and then you want to get a 1 in this first column. Then you want to get a 0 in the second column and a 1 next to that first 0. Then in the next, you want to have a 0 in that third row, first column, another 0 there, until you end up with that major diagonal where they're all 1s. Now, from this, we can then go to solve, and working backwards in a sense, we can convert this back to a equation with variables. So this would be 1x something, and then y, z constant. This would be a 0. This would be a y, z constant. But here, this is the key to it. This is a 1z equals some constant. So we now know what that z is. We then take this value, put it in the z position here, solve for the y. That gives you the y value. And then now that you have a z and a y, put it in this equation, solve for the x, and then you write your answer then as an ordered pair. Well, I guess we can use parentheses here. X, Y, Z. Just giving you an idea of where we're going with this. All right. Now we get to solve a system using matrix to solve this system. First thing, put it into the augmented matrix, which we see right there. Just verify everything. This is a 2, a 1, a 2, and 18. Yep, a 1, negative 1, 2, 9. 1, 2, negative 1, 6. Yes, this is good. Now, you might say, again, studying it, we want to exchange row 1 with row 2 because there's a 1 there. So let's see this. And let's go down. Keeping in mind there's more than one way to do it, we're exchanging row 1 and row 2. Why? Because in row 2, there was a 1 there already. We're just rewriting that. Now, we're going to use the matrix row operation to simplify matrix to row echelon form. Remember, we want a 1 here. For row 2, we want a 0. So what are we going to do? Again, study it. Well, we're going to replace row 2 by doing what to row 1? Multiply it by a negative 2. I want to be sure you see this. This negative 2 by row 1, and then add it to row 2. So we're going to, in a sense, do a negative 2 here to each of these items. So negative 2 times 1 is negative 2. Add it to row 2, positive 2. This gives me then a 0 that later I'll write in this form. Now, negative 2 times negative 1 is a positive 2, plus 1 gives me a 3 here. Negative 2 times 2 is a negative 4. Negative 4 plus 2 gives me a negative 2 in this spot. Now, negative 2 times 9 gives me a negative 18 plus 18 gives me a 0 in this position. All right, let's see it. I'll clear it up. And there we go. So we're starting to put it into the matrix of row echelon form. There's a 1. Now underneath that 1 is a 0. Now what we want to do is make this a 1 here and do something to make this a 0. Again, there's more than one thing you can do, but we'll follow what the book is showing us. We're now going to replace, we want this to become a 0 here, row 3 by multiplying row 1 by a negative 1 and adding it to row 3. This is what they're saying. So multiply row 1 by a negative 1 and then adding it to row 3. And you might say, well, what does this do? Well, it's going to make this a 0. And let's see this in action here. And once that's done, we see here now, we have a 0 in that first column. And what do we want to do to this? We want to make this a 1 now. So you can almost figure out what they're going to do, because they want this to be a 1 and eventually this to be a 0 here. Let's take a look. As I mentioned, there's more than one way to do it, so I see what they're going to do is take row 2 and switch it with row 3. Okay, let's follow up on that. And now they're going to replace or multiply row 2 by 1/3. All right, that's nice to do as well. So that causes this to become a 1, this become a negative 1, and this become a negative 1. And that's what you see here. Okay. Again, there's different ways to do it. We'll follow what's illustrated here. Now, this is what we have. So we have a 1 in our first row, a 0 in the second row, first column. We now have a 1 in the second row, second column. We want to make this 3 a 0. So what are we going to do to this second row added to the third row to make it 0? Again, they're going to show us, but we're brainstorming here. I'm going to take row 2 and multiply it by a negative 3. Row 2 by negative 3, and then add it to row 3. This is what I think they're going to do. And let's see if I'm right here. If I can get my slides to change. So checking this out now, it's replace row 2 by multiplying a negative 3 right over here, and then adding it to row 3. So this is going to be 0. This is going to be a negative 3 plus 3 gives this then a 0 as well. Now, negative 3 times negative 1 is a positive 3, plus a negative 2 leaves us with a 1. and then negative 3 times 0 is 0. So let's see what we end up with here. Clear this up. Now notice what we have. We have here a 1, underneath it is 0, then to the right of it a 1, and then 2 zeros. So we have our main diagonal with 1s, zeros there. So we have what we call row echelon form. Now the next step is to convert this to its algebraic form, where we put in our variables. So let's clear this up and do that. So this is going to be a 1x. This is going to be minus a 1y plus a 2z equals this. Now here there is no x value. This is going to be a 1y minus z minus 1, or equals a negative 1. And there is no x, no y. This is 1z. So in a sense, in our answer column, we now have a value for z. Z is 3. Okay, if z is 3, let's solve what this is. So this is going to be a negative 1 times 3 is a negative 3 here that I'm going to transpose. This now becomes a positive 3 minus 1, a positive 2. So we now have our y value is a positive 2. And now for this one, and we'll erase it. Now our z we said was 3, so 2 times 3 is 6. This will be a 6. Our y is a positive 2, so negative 1 times a positive 2 is negative 2. And this is x, and this equals 9. So this is going to be, on this side, a positive 4, that when I bring to this side becomes a negative 4. So my x value is a 5. Wow. So let's check it out and see what they're going to show us here. Clear this up. We did that. Now again, we write it in linear equations. And that's what we've done. Now we have a value for z that we're going to substitute there. And when we do that, our y is 2, and our x is 5. Wow. Again, these take a long time, and a good check of this, of course, is some of the computers, you can program them so that, in fact, they do get solutions for this just by plugging the matrix into the computer. All right, let's wind this up. For our last example, we're going to use the Gauss-Jordan elimination system. And here it's in some detail. I'll move it down so you can read it. Pause it at this stage. Okay, so if I show you, it works much better. Now this is the one we've been using, and we had gone to this stage where we have our main diagonal, and we want now to get rid of this -1 and 2, this -1 in the second row, and this is already at 1. So we have to do something with these two rows to make these two zeros. So all that we're left with is the main diagonal and then a value in this column. So there we are. No changes yet. Now we're going to replace row 1 by adding row 1 and row 2. So notice what happens here. This becomes a 0, which is what we're looking for, and we'll see it in this next slide. There we go. So we now have a new 1 with a 0 there. We want to get rid of this -1 and replace row 1 by multiplying row 3 by a -1 and then adding row 1 to it. And they're showing it there. Now we switch the rows around. Now we replace row 2 by row 3, and we end up with this. So now, what does this mean? Well, what did we say this was? This was 1x, and this one, 1y, and this one, 1z. Remember, these are equal signs. So we get our set then. X is 5, y is 2, and z is 3. And that's what we had before. And let's just see what they're showing us here. And there is our answer. Okay, until you do some of these and work with the notation and then the strategy to get there. Remember, there isn't just one way. You could modify a couple of these things and maybe work another line. But you need to follow the row operations again, and starting from that augmented matrix. All right.